Okay, these are the notes for the first day of section 1.7, and we're dealing with inequalities. So the first thing I want to remind everybody is that when we have an inequality and we have to multiply through by a negative, so we're solving an inequality. It's like if we were solving an equation, we could multiply through by 2, or multiply through by -2 maybe in the process of solving the problem. But here with inequalities, if we end up multiplying through or actually dividing by a negative number, then we have to change the direction of the inequality. So if it was greater than, we'll have to do less than, that kind of thing. Okay. So we call these linear inequalities because there's no quadratic term, right? There's no x squared, it's just x to the first power. So we're calling these linear inequalities because there's an inequality. It's not an equation. All right, so let's solve this very first example. So, usually the first thing we do is because it's linear, we move the x's to one side, the constants to the other. So let's do that. Let's move that 7 over. So we get negative 2x is less than, and then I'm subtracting 7 from both sides, so that gives me negative 12. Now notice I'm adding and subtracting at that point, so I don't have to change the direction of the inequality. It's less than, it's still less than. But now I'm dividing through by a negative in the next step. So it's going to be x is greater than a negative 12 divided by negative 2. Of course, that's just x is greater than 6. All right, now we can write it just like this. X is equal to 6, and then we're going to see down below in this table that we're going to also get into the habit sometimes of writing it as your answer in interval notation. So x is greater than 6 means that we're going to write our answer as 6 comma infinity parentheses. So starting at 6 going up to infinity. Now this looks a little bit like an ordered pair, but it's not. It's not x comma y. This is all the possible answers of x. They start at 6 and goes up to infinity. All right, so it starts at 6, but not including 6, and so we're using a parentheses. If it was something like x is greater than or equal to 6, then the interval notation for that would be a bracket 6 comma infinity. And then infinity is a value that we can never really reach, so we always have parentheses around it. Okay. All right, so this is really kind of how we're going to get to, we want to get you comfortable using interval notation, because you're going to start using interval notation in your later math classes too. So it's best if you get comfortable with that. And then often with inequalities, we'll graph our solution. So let's just say, okay, that's 6. In the past, you would do sort of an open circle and then like an arrow and shade in that arrow up to, something like that, right? What you can do. What we'll often do now, because we're using these parentheses kind of the same thing as an open circle. So I will put a parentheses at the 6 and then just kind of shade in, make an arrow shade into the right of it. Okay. So that's kind of how we'll graph some of these. All right. And then let's just talk about some interval notation. And then when necessary, if we're dealing with two variables, we're going to assume that A is less than B for this table. So types of intervals, so open intervals. So here we are saying that X, now this is a really fancy way of writing your solution in a solution set. So it's X such that X, so it's any X value such that X is greater than A. So you would just probably write something like X is greater than A, which is fine. And then in interval notation, how will that be? Anything greater than A. So it's a parenthesis. Let me, hang on, I'm going to leave some space because I want to make sure I can have room to do all 3 of these. So I need 3 intervals here. So, so it's going to be A and then up to infinity. And how would we graph that? Well, a parenthesis at A and then shading to the right. Okay, so greater than A. We'll start at A with a parentheses and opening it to the right. Okay. Here it's between A and B, not inclusive. So in that case, it's just going to be a parentheses, A, comma, B, and then a parentheses as well. And here we'll put a parentheses going in both directions, and we'll shade in between. Okay. In the past, we would do open circles, and that's fine if you want to do an open circle, but we're sort of getting this idea of this parentheses as an open circle. It's not inclusive of the endpoint. So it's not 3, but not A, but everything above it, not B, but everything below it. Okay. And then this last one, less than B. Well, we're going to go up to B, but we're going to go in the opposite direction to negative infinity. So it's from negative infinity up to, but not including B. So parentheses, negative infinity, comma, B, and then parentheses. And so what we'll do is we'll put a parentheses, but going in the opposite direction now, we'll shade all this in with an arrow. Okay. All right. Some other intervals here. This is inclusive. So this is x is greater than or equal to a. So now I'm going to do a square bracket, a, comma, infinity, parentheses. So this bracket is telling us that we're inclusive of a. So it's a and everything greater than a. So greater than or equal to a. So again, we'll do a little bracket there. Sorry, I'm obliterating the a, and then shading to the right. Okay. All right. The next one is greater than a, but less than or equal to b. So that's going to be a parenthesis at a, comma, b, and then a bracket, a square bracket on the end of b, because that's inclusive of b, but not inclusive of a. So put a parenthesis at a square bracket at b, shade in between. Okay. The next one, they've changed the and equal to got changed over to the a. So now we're saying that x is greater than or equal to a, but less than b. So as a interval, we're going to do a square bracket a, because that means it's inclusive of a, but exclusive of b. So b gets the parentheses, a gets the square bracket. All right, and then that's kind of the similar thing here, square bracket, and this time parentheses and shade in between. All right, and this one is less than or equal to b, so that means we're going to include the b on the high end and go all the way down to negative infinity on the low end. So parentheses, negative infinity, comma, b with the square bracket, and so we'll do a square bracket and shade below. Okay, so shade up to that bracket and then everything below. All right, this one is inclusive of both a and b, so we call that a closed interval. And so that's going to be closed bracket a and closed bracket b. So inclusive of a and b, and then everything in between. So this time we have 2 square brackets, and we're shading in between those. Okay. Disjoint means that x is less than b or greater than, less than a or greater than b. So everything below a, so that's going to be negative infinity up to a with a parenthesis, or we use the symbol, the disjointed or union symbol. So it's going to be this, or, and then this one's going to be anything greater than b. So parentheses b, comma, infinity. Both the a and the b here don't have n equals to include it, so they both get parentheses. So here we'll have parentheses shading to the left, and then at b a parentheses and shading to the right. So this is disjointed, anything below a or above b, but exclusive of a and b. And then all real numbers, that would just be negative infinity up to infinity is what we would do. You know, if you say all real numbers, sometimes we'll do like the squiggly R thing. But in interval notation, we write from negative infinity to infinity. And if I was going to graph that, I would just simply, graph the whole, shade in the whole number line with arrows on either end. Okay. All right. So that's kind of how the different solutions will look like if they're written in interval notation. All right, let's try B then. Solve and graph this inequality. Give your answer in interval notation, and so we want to graph it there. So, what I typically do is I'm going to move the x's in one direction and the y's in the other, and I usually start by moving the smallest axis. The -4 axis, the smallest, so I'm moving it to the right, and I'll move this 8 to the left. By subtracting it. So we get -5 is greater than or equal to 6x. And notice I did not multiply or divide by any negatives, right? So I didn't switch the direction of the inequality. But now I'm going to rewrite it because we always want our x term on the left when we're finished, when we're all said and done. So I'm going to rewrite this 6x is less than or equal to -5. Now, I changed the direction of the inequality here because I've rewritten the equation. I flipped it, right? So this is telling me, right, that this is less than this. Of course, we read it from left to right, so that's why we want to start with our x. So it's really -5 is greater than or equal to 6x. But if I were to read that in reverse, it'd be 6x is less than or equal to -5. And so that's why I've written it like this. And then finally, the last thing we want to do is x is less than or equal to -5/6. Okay. And then we wanted to write that in interval notation. So we want to, it's less than that. So that's going to be starting at negative infinity up to -5/6. And we'll do a bracket because it's inclusive of our boundary. Okay, so then we just want to graph that. What can we do? We could do -1 here, and we could do 0 here. And then it's not quite at -5/6. So, it's somewhere here, right? But let's go ahead and use our new notation instead of a closed circle. I'm just going to put a bracket there and then shade to the left. Okay. All right, and then letter C then. We want to find the break-even point here. So that means at what point do we start making a profit? Typically is what that means. So if the revenue and cost of a certain product are given by, and this is the revenue, R is equal to 45x, and C, that being the cost, is equal to 30x plus 5,250, where x is the number of units produced and sold, at what production level does revenue at least equal cost? So that if we kind of take this and write it as a sentence, that would be revenue is at least equal to. So that means it's at least that, or it's greater than or equal to cost, right? So that's kind of what this is converted to. And so we just plug in our equations then. So that's 45x is greater than or equal to 30x plus 5,250. And then we'll just move the 30 over. That's what, 15x is greater than or equal to 5,250. And then we'll divide both sides by 15. So x is greater than or equal to, and I think that goes into just evenly, 350. So if we make 350, then at that moment, the cost and the revenue are equal. The revenue you bring in is covering the costs. So if we make more than that, right? So X is greater than or equal to 350 means that your revenue will exceed your costs. That's what you actually want, right? So it's at 350 that it's exactly equal, but we want greater than or equal to. So we would have to make and sell at least 350. How would we write that in an interval notation? Well, 350 is the lower bound. It's inclusive, so we have a square bracket, and then up to infinity with a parentheses. Okay, so that's how our answer would look in interval notation. All right, and then our last problem on the next page then is letter D, and so it's asking us to solve this, solve and graph that inequality. So let's work on that one. All right, so solve and graph. And this is a compound inequality. So there's a couple of approaches that we can use for this. We could break it into like that inequality and that inequality. So we could break them up into two parts if we wanted, or we could just leave it as one for right now. And so that's what I think I'm going to do. I'm going to treat it as though there are two inequalities here, because really there are. So think of it as, solving for x, right? Get x by itself. So when we move 8 to the other side, we sort of have to move it to all, the other two sides, these outer ones. So I'm going to add 8 to both sides there. And so that's going to be 9 is less than or equal to 6x, which is less than 12. And then I'm going to divide through by 6. So I'm going to divide everything by 6. We get 9, 6, which is going to be 3 halves, is less than or equal to x, which is less than, and I divide by 6, I get 2. Okay. Now, what's kind of nice about this is this is sort of an implied and in here, compound inequalities. We only use this compound inequalities when it is an and. So it's really, what ends up happening is it's really x is greater than or equal to 3 halves and x at the same time is less than 2. All right, so it's x is greater than 3 halves. And at the same time, x is less than 2 is really what this is saying. But, this is a compound inequality. We can leave it like this. And it's kind of nice because x is sort of visually in between these two values. So it kind of lends itself very nicely to the interval notation. On the left, we have 3 halves in a bracket because it's n equals 2. And then on the high end, we have 2, and that's a parentheses because the equals is not included. All right, so this sort of is nice. I mean, this is maybe how we would think of it sometimes if we want to break it up into 2, but leaving it as a compound inequality is kind of nice too because it helps us with the interval. You can kind of see more easily with the interval. And then also graphing. Let's see, let's do 0, 1, 2. And so actually, I'm going to use a different scale here so that these are a little bit further away. So 0, let's call this 1 and call this 2. That way it's a little bit easier to graph this. And you can see that we're at 1.5, which is here. So I'm going to do a square bracket. And then at 2, I'm going to do parentheses. And I'm just simply shading in between those two. Okay? Makes sense? So we're at 3 halves. And then 3 halves, no, sorry, I did, 3 halves, right? 1.5 is 3 halves. And so from 3 halves to 2, and then we're just shading in between. So with these inequalities, we want to sort of graph them, but also write them in interval notation. So interval notation and be able to graph them. All right, so your first, the homework on your first section here, 1.7, 1.71, is listed there.